The 3D weldless molding system solves all problems covering plastic molding quality control troubles, delivery, and cost. Its use prevents generation of weld lines and allows high-quality plastic molding having no flow marks, sink marks, or warping. Already, 50 years have passed since plastic molding started in Japan. Until now, many techniques have been considered to eliminate weld line shrinking and warping. However, it took a long time to correct the gauge position of the mold several times and enable the move to mass production. This resulted in unnecessary processes such as annealing, sanding, and excessive painting for hiding discrepancies of molded products. It not only raised costs, but also prolonged manufacturing time and delivery dates. The 3D weldless molding system solves all these problems. It allows high-quality molding without weld lines and flow marks, reduces delivery time by eliminating unnecessary work, and permits considerable cost reduction. The system has 3 technological advantages. First, realization of the heating and cooling molding technique, which is ideal for plastic molding. Second, production of a 3D weldless mold having the structure to enhance heat conduction to attain maximum efficiency. In other words, high quality and high cycle molding without welds, sink marks, or warping. And third, development of a mid-air multi-face die and molding machining device called the Vertical Machining Center with Rotary Smart Vise. Now, efficient 3D weldless molding of complex structures has reduced manufacturing time, allowing production of high-precision molds. Our new heating and cooling molding technique overcomes these problems. Advantages are obtained by controlling the mold temperature within one molding cycle due to using the steam from the boiler and the water from the cooling tower. First, the mold is preheated to a temperature higher than the thermal deformation temperature of the resin to be molded before injection. Then, the molten resin is injected, thereby achieving good surface quality, having no weld lines. Next, cooling starts after completion of injection of the molten resin. Using water at room temperature, the mold temperature is quickly lowered to below that of thermal deformation of the resin. In this manner, solidification speed of the resin is increased and the molding cycle is shortened, with no problems of sink marks or warping. The 3D weldless mold was developed to effectively realize heating and cooling molding. But first, let's look at molding conducted by a conventional mold equipped with a straight channel. In flat surface molding, Since thermal conduction is not uniform over the cavity surface, unevenness occurs in product quality. For cavity surface temperatures higher than the deformation temperature, the weld lines are not possible because the resin has sufficient fluidity. However, if the cavity surface temperature is low, the resin starts solidifying. Also, the resin does not properly mix and weld lines appear. Even by heating the entire cavity surface to the same temperature, cooling and mold cycle times are prolonged. Now, the 2D weldless mold with the slant channel open along the cavity surface. With heating and cooling molding using the 2D weldless mold, improvement is obtained in three-dimensional shaped products as compared to the conventional straight channel. However, for products of complex shape, the same problems occur as in the case of ordinary molds. The 3D weldless mold, with its improved structure, enhances thermal conductivity to the maximum limit. A slot is machined on the back of the cavity surface according to the shape of the product, and the plate is machined accordingly. With this newly formed water channel, the problem of uniformity of heat conduction is solved, allowing the mold surface temperature to be raised and lowered in a shorter time. Taking this automobile part as an example, it is now possible to raise the temperature at a rate of about 10 degrees centigrade per second. The time required to raise the temperature of the cavity surface from the 60 degrees centigrade mold temperature to 120 degrees centigrade is only 6 seconds. The mold temperature can be raised within the time of opening for removing the product. Moreover, the cooling time can be shortened because there are more channels as compared to the conventional mold. The result, high cycle molding without weld lines, sink marks, or warping. This comparison is for the cases with and without performing heating and cooling molding. The comparison reveals that heating and cooling molding makes the resin surface quality considerably different. Plastic molding using heating and cooling and the 3D weldless mold provide a number of other merits. Glass fiber and carbon will not be surface exposed, and a clean surface gloss is achieved. Fluidity of resin increases, making thin product molding possible. Even in thick product molding, the molding cycle can be considerably shortened. Surface gloss can be obtained from ordinary resin and resin with a foaming agent. Moreover, transferability of embossment increases. It is also effective for reduction of the molding cycle of biodegradable plastics. The biggest problems of 3D weldless mold molding are the complexity of machining and precision processing. 3D weldless mold has a two-ply cavity construction. Both sides of the product side cavity are three-dimensionally machined. With ordinary machines, since it is difficult to directly clamp the workpiece in a vise or on a table, and it is necessary to machine by alternately turning over the upper and back surfaces several times, the number of preparation steps increases. Also, due to machining deformation, and errors during repeated setups, it is difficult to achieve the desired precision, and various adjustments become necessary. Consequently, lead time and cost significantly increase. These problems are solved by the mid-air multi-face die and mold machining device, or the vertical machining center with rotary smart vise, which allows machining of various surfaces in one chucking. This rotary smart vise consists of a rotating table installed on the three-dimensional vertical machining center table and a hydraulic tailstock. As the workpiece is clamped between them, it floats in the air. In this state, an arbitrary surface of the workpiece is indexed, and machining can be repeated. A cross V-slot is machined at both ends, sandwiching the workpiece. Engaging the grooves with claws on the rotary vise side allows heavy machining, and the workpiece remains firmly attached. The rotary smart vise has made it possible to machine 3D weldless molds with high precision and less setup steps.